Hi guys, today I'll be making a video about projectile motion. So this is a kinematic problem in 2D or 3D. So the question is, a footballer kicks a ball. It sets off with a velocity of 15 meters per second under an angle of 35 degrees to the ground. And we have to find out how long it is in the air for and what the range is. So basically that's how far it goes. So we work the first one out by finding the y components of this question. So we know it sets off with a velocity of 15 meters per second, and this is initial velocity. So the initial velocity in the y direction, we break it down into its components. So it'll be 15, and because it's in the y direction, it'll be sine. And it's at an angle of 35 degrees to the ground, so it's sine 35. And that's our initial velocity in the y direction. We know the final velocity in the y direction will be 0 because it's asking how long it will be in the air for. So when it's not in the air, it'll be on the ground. Should have also drawn a coordinate system, so we're defining y to be y upwards is positive and downwards is negative. And here's the x-axis. So this is the angle and this is the velocity. So we know the initial y position is 0, and we also know the final y position is 0. And the acceleration in the y direction will be minus g, since our y downwards is negative. So we've now got enough variables to plug it into an equation, and we can use this one. Y equals initial position at y plus initial velocity at y multiplied by t plus, actually it'll be minus a half g t squared. And now we have this equation, we can solve for t. So we know that y is 0, so is this, but we'll just leave this out. The initial velocity, that is 15 sine 35 multiplied by t. And then here we have, still have minus a half gt squared. We'll leave it as that because we're going to want to factor now. So 0 equals, we're going to factor the t's out. So t on the outside of the bracket multiplied by 15 sine 35 minus a half gt. And now we can divide this t by 0, which gets rid of it. So we end up with 0 equals 15 sine 35 minus a half gt. And now we can start solving for t. So I'll just get another sheet of paper here. So if we add the 15, if you can see, if we add this 15 sine 35, we get that on the left hand side. So 15 sine 35 now equals a half gt. Multiply by the 2, we get 2 times 15 sine 35 equals gt. And then we just divide by the g to get 2 multiplied by 15 sine 35 over g, and g of course is 9.8. And let's work out what the time is. So plug it into our calculator. Remember now to have this in degrees. So the answer is 1.76 seconds. So that's a reasonable answer, so we shall stick with that. Now we have to find the range. So the range is simply how far the ball goes in this x direction. So we know, so what we want to find is x. So let's put x as r. The initial x position was 0. The initial x velocity, well, that'll be 15 cosine 35. And then acceleration in the x direction is always 0. So now that we have this, and oh yeah, of course, the time in both y and x components is exactly the same, so we can use this time to work it out. And then we use exactly the same equation, just in x variables. So x equals the initial x position plus the initial velocity in x multiplied by t plus a half the acceleration in the x direction, t squared. Now, of course, acceleration in the x direction is 0, so we don't need to worry about this. This is 0. So all we need to worry about is this bit. So initial velocity in the x direction is 15 cosine 35 multiplied by the time, which is 1.76. So, and this gives us the answer for r. So let's work that out now. 1.76 multiplied by 15 times cosine 35. And that gives us a range of 21.6 meters. And this is the procedure we always use for projectile motion questions. We usually find the range by using the x components and how long it is in the air for with the y components. So I hope you find this tutorial useful. I'll be making some more tomorrow. Thanks for watching.